Um, this is Bhavani. Today my presentation topic is C MOS inverter. Uh, the agenda of C MOS inverter is the C MOS inverter symbol and truth table and circuit diagram and working of inverter and dynamic characteristics and VI characteristics of C MOS inverter and applications of C MOS inverters. Here, what is inverter? The basic definition of inverter is it converts DC current to alternate current. Mean DC means direct current to alternate current. And these devices never generate any kind of power because the power is generated by the DC source. CMOS inverter. What is CMOS inverter? CMOS inverter is defined that uh, is used to generate logic function is known as CMOS inverter. Here, what is logic functions? Like the logic elements like inverter reverse the applied input voltage in digital logic circuits, binary and arithmetic and switching or logic functions. Mathematical manipulations are the best performed through the symbols 0 and 1. Here, this is the CMOS inverter, and this is the symbol, and this is the truth table. Here, we can observe one thing is this symbol is indicates the NOT gate. So, NOT gate is indicates that the symbol of CMOS inverter. Here, we apply the input is high, then it converts into the low. Apply the low, it converts into high. So this is the truth table of CMOS inverter. Here, if the input is logic 0, then the output will be the logic 1. If the input is logic 1, then the output is logic 0. This is the truth table. And this is the CMOS inverter circuit diagram. We can observe that in the CMOS inverter, the CMOS inverter is a combination of both PMOS and NMOS. PMOS means pull up transistor, is a NMOS is a pull down transistor. These are connected in series combination, and the NMOS transistor is connected to the drain and gate terminals, and voltage supply VDD is connected to the source terminal of PMOS, and gate terminal is connected to the source terminal of NMOS. Source terminal of NMOS. The input voltage VN is connected to the both gate terminals of the transistor, and the output Vout is connected to the drain and terminal of the transistor. This is the construction of CMOS inverter. Okay, here the VDD is a drain and sorry and the working of CMOS inverter. Here, when the low input voltage is given to the CMOS inverter, then the PMOS transistor is switched on and NMOS transistor is switch off by allowing the flow of electrons throughout the gate terminals, then generating high logic output voltage. Means, for example, we apply the low input voltage. I means zero. Low input voltage means zero. Here we apply the logic zero. Now here PMOS is zero. Then it will on, and NMOS is zero. This transistor will be off. Then the VDD is directly go to the Vout. I mean um, the output is a high logic output. This is the closed. And similarly, the input is applied to the logic high. I means 1. The PMOS is 1 and NMOS is 1. The PMOS, when PMOS is equals to 1, the transistor is closed, and NMOS transistor is 1, then this transistor is opened. Here the current is not flow through the PMOS. Here we can observe that here the capacitance is there. Um, CL, load capacitance. What is the purpose of capacitance? Is capacitance is to store the charge. Here we don't know how much element, how much amount of charge will be stored. Here some amount of charges are stored. Here this charge will be decreased to the ground. Okay, then the output of the CMOS inverter is 0. Okay, this is the working of CMOS inverter. Okay, here This is the dynamic characteristics of CMOS inverter. Here we have to take, I am taking the, this is the input waveform. Here low to yeah, low to high. Okay. Then output waveform is reverse of input waveform. Here low to high, here high to low waveform. Here we can observe the two things like are TF and TR. You know what is the TF and TR? TR means rise time and TF is means fall time. Rise time means it increasing the yeah, sorry, increasing signals from 10% to 90% is the rise time. The fall time means to drop the signals from 90 to 10% or decreasing the signals from 9 to 10%, 90 to 10%. This is the TF and TR. And what is the edge rate? You know what is the edge rate? Is the edge rate is the combination of TF and rise time and fall time. So the TRF is equals to TR plus TF by 2. This is the dynamic characteristics of CMOS, and this is the VI characteristics of CMOS. And we observe that this is the static characteristics of CMOS. In it, the quality of inverter can be measured frequently by using VTS. VTS means voltage transfer curve, which is plotted between the input VN and output Vout. Here we observe that this curve is the VTS. VTS means voltage transfer curve. Okay, the voltage transfer curve specifies that for less input voltage. Here we giving the less input voltage, then the circuit generates the high output voltage. Here we generate the less. Here whereas the we give the high input voltage, then the circuit generates the zero output voltage. This is the voltage transfer curve. Here the VI characteristics means voltage and current characteristics of characteristics. Um, Here we observe that in a voltage transfer curve, we have the five steps are there. This is the five regions, 1 to 5 regions. For example, we take first region. Here we observe that when Vn 0 volt, in region 1, this is the region 1. In region 1, the input voltage is given to the 0 voltage. Then PMOS is equals to on and NMOS is off. Then output is VDD. So here there is no current flow between the VDD and VS. Here observe the below. Here there is no current flow between the VDD and VS in first region. So similarly, the first region is opposite to the fifth region. Here we are given the Vin is equals to here first region we are giving the 0. Here we are giving the 1. So logic high or VDD. Here the NMOS transistor is on and PMOS transistor is 0. Okay, then the output is 0. You know why? I already explained the working. Here here also we observe that in the fifth region there is no current is flow between the VDD and BS. Okay, and next we go to the second region. We observe that the PMOS in linear and NMOS in saturation region. How it will become is then the input voltage is slowly increased, and when the input voltage crosses the threshold voltage of NMOS transistor, and NMOS transistor enters into the saturation region, and PMOS transistor is act as a linear region. Okay, when Vn greater than Vth, at the time the PMOS is a linear and NMOS is the saturation region. Here the we observe the VTS curve is we observe that is slowly decreasing. Vot is slowly decreasing. So then the IDS current is slowly increases. Here the IDS current is slowly increases. Actually, uh, the IDS current is slowly increases. We observe that. Then the region second is opposite to the region 4. Okay, here we observe that PMOS is saturation and NMOS is linear. Okay, when the input is just less than VDD, okay, by threshold voltage of the PMOS transistor, then the PMOS transistor is said to be saturation region and NMOS transistor is said to be linear region. So then The output decreases moving towards to zero. Huh? Here we observe that the output is decreasing and moving towards to the zero. Okay, then the IDS current is slowly decreases. So here we observe slowly decreases. Okay, decreases. Then the remaining region is third region. This is the important region. Here the current waveform is formed. Okay, in the third region, at this condition, in third region, at the condition and at which and what is that condition? Vn is equals to V out is equals to VDD. At this condition, in the region, in the PMOS transistor and NMOS transistor, the both transistors are in saturation region. Then the current IDS is maximum between the VDD and VSS. Here, the high current flows between the VDD and VS. Okay, both the transistors are in on state. The both transistors are on state. Then current will be then current flow, high current flow between the VDD and VS. Okay, this is the saturation region. Okay, so we when the saturation region will come, here the condition is satisfied. Vn is equals to V out or is equals to VDD. At this condition only, the both the PMOS and NMOS are in saturation region. And then the current is high current is flow between the VDD and VSS. This is the VI characteristics of CMOS inverters. And the applications of inverter is yeah, the inverters are applicable in ICS, integrated circuits, and microprocessors and static RAM. And it is applicable in a microcontroller, data converters, and image sensors and transceivers. This is the total information about CMOS inverters, circuit diagram, symbol, and truth table, and working, and dynamic and static characteristics, and PI characteristics of CMOS inverters. Thank you. Thank you very much.